Today, we're exploring the quiet revolution that's transforming the way we power our world. Solar and wind energy. Both have their unique strengths and challenges, but which one truly holds the key to a sustainable future? Stay with us as we unfold the science, technology, and impact behind these two renewable giants. Let's start by understanding what sets these technologies apart. Solar power captures energy from the sun using photovoltaic cells, which are mostly made from purified silicon. When sunlight hits these cells, it knocks electrons loose, generating electricity. Silicon, which makes up a large part of sand, might seem ordinary, but in the cleanroom conditions where solar cells are fabricated, it's anything but simple. Meanwhile, wind power is all about harnessing kinetic energy. Giant turbines spin when the wind blows, and inside, precision-engineered components convert that mechanical movement into electrical energy. These turbines rely on cutting-edge materials like carbon fiber to craft the enormous lightweight blades that are crucial for capturing even the slightest breeze. Let's peel back the layers of efficiency. Wind turbines are impressive machines, converting up to 40% of wind energy into usable electricity. That's partly thanks to the sophisticated design of turbine blades and the gearless direct drive technology used in modern wind farms. On the other hand, solar panels are evolving rapidly. While most panels convert 15 to 20% of sunlight into electricity, breakthroughs in materials like perovskites are pushing efficiency beyond 22%. Unlike traditional silicon panels, perovskite-based solar cells are flexible and lightweight, opening new possibilities for where and how solar power can be deployed. It's not just about rooftops anymore. Now, let's talk about the environmental cost, because even clean energy comes with trade-offs. For solar power, the challenge starts with mining the silicon used to make PV cells. But that's not all. Solar panels also require rare earth elements like indium and gallium, which are sourced through environmentally invasive processes. And when these panels reach the end of their life cycle, recycling remains an uphill battle. Right now, only around 10% of solar panels are effectively recycled. Wind power, in contrast, has its own environmental hurdles. Each turbine takes up significant land or offshore space, and the massive blades, often longer than a football field, can pose a threat to local wildlife, especially birds and bats. Wind farms also require rare materials like neodymium for their magnets, which are essential for the turbine's generators. Let's take a look at these technologies in real-world scenarios. The Ivanpah Solar Facility in California is a cutting-edge example of solar thermal technology. Rather than using standard PV cells, it employs thousands of mirrors to focus sunlight onto a central tower, creating steam to drive turbines. It's capable of powering 140,000 homes, but its environmental impact has raised concerns, particularly around the bird populations that collide with the intense beams of focused sunlight. In contrast, offshore wind projects like the Hornsea Wind Farm off the coast of England are showcasing the future of wind energy. This farm will be the largest of its kind, harnessing powerful and steady ocean winds to generate electricity for over 1 million homes. Offshore wind is a game changer, offering more consistent energy than onshore sites. But building and maintaining these structures in deep water requires cutting-edge engineering. Where are we headed next? In both solar and wind, the future is all about maximizing output and minimizing footprint. Solar researchers are hard at work on multi-junction cells, which layer different materials to capture a broader spectrum of sunlight. These advanced cells can potentially push solar panel efficiency past 40%. Wind energy, meanwhile, is looking to the skies. High-altitude wind turbines that float like kites could one day access stronger, more reliable winds at higher elevations. The most promising development, however, may be hybrid systems. By combining solar, wind, and energy storage technologies, we can create more reliable, consistent power supplies. In this future, when the sun isn't shining, the wind could be blowing, ensuring that clean energy flows around the clock. As we've seen, both solar and wind power are essential pieces of the renewable energy puzzle. The choice between them depends on location, cost, and technological advances. Solar thrives in sunny, open areas, while wind farms capture the energy of the skies. But the real power lies in combining these technologies, pushing forward with innovation, and shaping a future where clean energy is the norm, not the exception.